Here we are given a piecewise function and you're to find the Fourier series of it. Now usually if you have a piecewise function, then the Fourier series becomes really hard, and therefore they would normally just ask you for the first 5 non-zero terms, or maybe they might just ask you what's A1 or like B2, stuff like that, okay? But the way you get it is same as the usual, because you're just making use of these formulas. Now notice that the function is defined from -5 to 5, so the L value should be 5. So these formulas should be looking like this. Oh, there is actually one big difference here. When you apply these even and odd arguments to simplify integrals, you can't do that if you have a piecewise function. And that's because you no longer have a symmetry, because your function is only defined on one side and not the other. There are some rare occurrences where the piecewise function itself is given as an even function or an odd function. In that case, you could, but that's rare. Usually, you don't get to use any even and odd to simplify your integrals. Okay, so now let's try to calculate these. But if you try to calculate this, you will realize that you need to break up the integral into two, so that because f of x is 6x plus 3, and this fx from 0 to 5 is 2 minus 4x, then you can use these formulas, and it makes the integral become concrete, and therefore you can do the integral without any problem. And you can do the same thing for Bn as well. Alright, so we're just going to calculate these two integrals. However, despite just having two integrals, you have to treat this first formula as two formulas, because this is actually two formulas, one for n equals to 0 and another one for n greater than or equal to 1. Okay? And the reason for that is if you plug in n equals to 0, you see that you get cosine of 0. See, I replaced n by 0, so this n is now replaced by 0, this n is replaced by 0. And because you have cosine 0, which is 1, you have an integral without any trig functions. And that's completely different from the case when n is 1 or greater. Okay? This is just a simple integral, which you can just do the integral. And you have to plug in these endpoints and you subtract. So when you plug in 0 is 0. When you plug in -5 squared is 25 times 3, that's 75. And -5 times 3 is -15. So 75 minus 15 is what you need. But that value has to be subtracted, because this plugged in minus this plugged in. Same goes here. 5 times 2 is 10. 5 squared is 25 times 2, that's 50. And minus 0. So that's what you get. And simplifying that, you see that the value of a0 is -20. Okay, so now let's calculate an for n1 or greater. This time, because n is not 0, you end up with a trig function times a polynomial, in which case you need to use integration by parts. Now the way I like to do the integration by parts is by using something called the tabular integration. This is often very easy, especially advantageous when you have to do Fourier series. So if you don't know the tabular integration, please watch one of my videos to introduces that, and you'll probably be able to learn it easily. Okay, so you have this table, and what I do is you put the 6x plus 3, the one to differentiate, on one column. The other one you integrate, and then you keep differentiating. 6x plus 3 differentiates to 6, 6 differentiates to 0. On the other hand, cosine integrates to sine, but this coefficient of x, you have to take the reciprocal and put it in front when you do the integral. So you do that again. Sine integrates to negative cosine, and you have another reciprocal, 5 over n pi multiplied, so you get 25 over n squared pi squared. And the first column, you always start with plus, and you alternate plus, minus, okay? And once you're done with that, you can multiply things like this. You go across and then tilt down, okay? Same thing across, and then tilt down. So this is multiplied, and this is multiplied. So let me show you what I get from that tabular integration. So this is what you get. And then so you can see that I in fact just multiplied positive times 6x plus 3 times 5 over n pi sine n pi over 5x, just like this. And then negative times 6 times this is multiplied. And then you have to do another tabular for the second part, which is more work. But if you have seen how this is done, you can kind of see that the only difference between the tabular for this one and tabular for this one is that this column is now replaced by 2 minus 4x and the derivative of 2 minus 4x, which is negative 4. So basically you just have this exact same integral, except that 6x plus 3 is now replaced by 2 minus 4x, and 6 is replaced by the derivative, which is negative 4. So I kind of get the next one for free. Now you still have to plug in 0, negative 5, and 5 and 0. So let's continue. When you plug in 0 into sine of 0 is 0, so that goes away, okay? And when you plug in 0 here, cosine of 0 is 1. And negative 6 times negative 25, that's 150 over n squared pi squared. So this is obtained by plugging in 0, okay? So maybe I should make it red and then put this thing here as red, okay? So that this 0 makes this come up, okay? Now when you plug in negative 5, that's a different story. That's when you plug in negative 5 into n pi x, that gives you sine of negative n pi. And sine is an odd function, which means that negative can come outside. So it's negative of sine of n pi. And sine of n pi is 0. I hope you know that. And then another one is cosine n pi is negative 1 to the nth power. Similarly, if you plug in negative 5 here, you get cosine of negative n pi. But cosine is an even function. Even function just eats up the negative sign. So this is the same as just cosine n pi, which is just negative 1 to the nth power. Okay, so that's why you get negative 1 to the nth power when you plug in negative 5 in here. Okay, and then the coefficient is same, but you have to subtract. That's why you have a minus here. And I'm doing the same thing, this time plugging in 5 and 0. Either way, sine term will give you 0, so this really doesn't create anything. Everything just comes from here. When you plug in 5, you get cosine n pi, which gives you negative 1 to the nth power. Negative times negative times negative is negative. 4 times 25 is 100. When you plug in 0, it's positive 1. And then because you're subtracting, you have 4 negatives, so it's plus. Okay, so you have this integral. And what I just did was I can switch places, right? So I switch places, and 100 divided by 5 is 20. And because they both have 20 over n squared pi squared, I can factor that out. So this is what I get. Same thing over here. 150 divided by 5 is 30. They both have n squared pi squared, and if I factor it out, you get 1 minus negative 1 to the nth power. And if you look at this, you see that this and this is common, so these two terms are like terms. All you have to do is add 30 and 20, and that's your answer for AN. Okay. Now let's move on to BN. Same story here. You need the tabular integration. These first two columns are the same. If you integrate sine, you get negative cosine. Integrating negative cosine gives you negative sine. So this is what you get, and then again you multiply like this. So you get this multiplied by this multiplied by this gives you here. And then again, this multiplied by this multiplied by this gives you the second part. And one more time, you just reference this integral, but replace 6x plus 3 by 2 minus 4x, and 2 minus 4x derivative is negative 4. 6 is replaced by negative 4. So you simply have this integral. Now you have to evaluate. It's very similar to the previous one. You have to remember that cosine n pi or cosine negative n pi, they both give you negative 1 to the nth power. Whereas if you plug it into sine of 0 or sine n pi, they both give you 0. So these two really don't give you any terms. So just ignore these. When you plug in 0 and negative 5 over 5, they both give you 0. So the only non-zero parts are created by these two things, the cosine ones. When you plug in 0, that's 1. Cosine 0 is 1. And then when you plug in 0, that's 3. 3 times 5 is 15. So negative 15 over n pi is what you get when you plug in 0. Okay, and then when you plug in negative 5, you get negative 1 to the nth power as before. And if you plug in negative 1 times, actually negative 5, negative 5 times 6 is negative 30 plus 3. So you end up with negative 27 if you plug in negative 5. But negative of negative is positive 27 times 5 is 135, but you have to subtract. So there's a minus here for the subtraction. And I've done the same thing over here. 5 times 4 is negative 20. So this is negative 18. Negative of negative 18 is positive 18 times 5 is 90. And then when you plug in 0, this goes away. You get negative 2 times 5, which is negative 10, but you're subtracting, so it's positive 10 over n pi. Okay, so once you have this, you can multiply the 1/5. They're both divisible by 5. So you get these terms, and if you look at this closely, these two are like terms. Negative 3 plus 2 is negative 1. And these two are again like terms. Negative 27 plus 18 is negative 9. And therefore, this is what you get as a simplification. All right, so we got all the values of the coefficients. A0 is negative 20. AN is 50 over n squared pi squared. 1 minus negative 1 to the nth power. Bn is negative 1 over n pi minus 9 over n pi, negative 1 to the nth power. Okay. Now what we do is we are going to write down the Fourier series as the final answer. The very first number you have to divide by 2. Don't forget that, okay? So that's what you have for the first one. And then you have A1. A1 means you plug in 1 here. And when you plug in 1 here, you get 1 minus negative 1, which is 2, right? So 2 times 50, that's 100. Okay? So you get 100 over n squared pi squared. But remember, n is 1, so you end up with 100 over pi squared. Okay, n is 1. All right, so that's the very first value, and it's cosine n pi over 5. But n is 1, so it's pi over 5x plus, and then b1 would be, when you plug in 1, you get negative 1 minus 9 with negative 1. So that's negative 1 plus 9, which is 8. Okay, and there's also the n pi with n equals to 1, so it's 8 over n pi sine pi over 5x. And then when n is 2, let's see, 1 minus, negative 1 squared is just 1, right? But 1 minus 1 is 0, right? So a2 will become 0. Okay, that's not good because we're looking for non-zero terms. And this just happens to be 0 coefficient, so it's 2 pi over 5, n pi over 5x, right? But n is 2, so it's 2 pi over 5x, but that's 0, so this doesn't count. And then when n is 2 here, negative 1 to the square, that's positive 1. And then you get negative 1 minus 9, which is negative 10. So you end up with 10 over 2 pi, because n is 2, negative I mean, and therefore this is negative 5 over pi. Okay, so you need negative 5 over pi sine 2 pi over 5, and then because we have 1, 2, 3, 4 non-zero terms, this is 0, we need just one more. So let's go to A3. When you plug in 3, 1 minus, negative 1 to the third power is just negative 1, so that's again 2. 2 times 50. 2 times 50 is 100. N is 3, so it's 9 pi squared cosine 3 pi over 5x and plus da da da. Okay, so that's the Fourier series. And if we add like 1,000 terms, it would be very similar to this piecewise function given.